Okay, think about the last glass of water you had. Pretty simple, right? Well, what if I told you that glass of water is actually tied into this huge global to-do list for the future of, well, all of us? Let's follow that thread. And that's the big question, isn't it? How does something so small and everyday connect to something so massive? We're going to trace that line all the way from this giant global plan right down to the nuts and bolts, the actual engineering that fills your glass. But first, we've got to understand the plan itself. All right, first up, the plan. And look, this isn't your average to-do list. This is more like a blueprint for the entire planet. So back in 2015, the United Nations put out something called the Sustainable Development Goals, or SDGs for short. And this thing is a huge deal. We're talking 17 goals all linked together with the aim of creating a better world by 2030. You can really think of it as a shared roadmap for, the future of humanity and the planet. Okay, so these 17 goals aren't just random. They're built on three core pillars. First, you've got the society pillar. That's all about human needs, things like health, education, food. Then there's the economy pillar, which is focused on growth and well-being. And finally, the environment pillar, which is all about managing our footprint on the planet. And here's the kicker. The whole idea is that you have to balance all three. You can't have real, lasting progress if you sacrifice one for the others. It just doesn't work. Now, among all 17 of these big goals, there's one that kind of stands out. Not just because it's important on its own, but because it's the key that unlocks almost everything else. And yeah, you guessed it, it's water. This is SDG 6, and its mission? It's crystal clear. Make sure everyone, everywhere, has access to safe water and sanitation. I mean, it sounds so straightforward, doesn't it? But getting this one goal right, man, it opens the door to making progress on pretty much all the other goals. Yeah, UN Water has this great phrase for it, a dynamic two-way interdependence. It sounds a little academic, but it's basically a fancy way of saying that water isn't just sitting off in its own little corner. Nope, it's the linchpin. When you manage water better, it helps you hit other targets. And at the same time, making progress on other goals often depends on having that reliable water supply. See? It flows both ways. And you can see that web of influence so clearly. I mean, think about it. How is water tied to gender equality? Well, when girls aren't forced to spend hours a day fetching water, they can actually stay in school. What about the economy? Industry can't run without water. Health? That one's a no-brainer. The bottom line is, you just can't make real progress on these other massive challenges if you don't get the water situation sorted out first. But it's not always that simple. These connections can be tricky. Sometimes making progress in one area can accidentally create problems in another. So we have to think about allies and, well, adversaries, or as the experts call them, synergies and conflicts. It's actually a pretty simple idea. A synergy, that's a total win-win. Progress on one goal gives a boost to another. Awesome. But a potential conflict, that's a trade-off. It's where pushing ahead on one thing might accidentally hurt another, unless you're incredibly careful with your planning. Okay, here's a perfect example of a synergy in action. When you put clean water and safe toilets in schools, what's called WASH, you see these direct positive impacts on education and gender equality. The kids are healthier, so they miss fewer days of school. And this is so important. It helps keep teenage girls in school, which has these amazing long-term ripple effects for them and their entire communities. And now for the other side of that coin, a potential conflict. Let's take goal 9. That's all about building up industry and infrastructure. Super important for economic growth, right? But what if that brand new factory just dumps its waste untreated straight into the river? Well, you've just wrecked your water quality and hurt the ecosystem, which sets you way back on goal 6. This is why that integrated planning is so critical. You have to think about how all the pieces fit together. Okay, so let's zoom in. We've been talking high-level global goals. Let's bring it right down to the ground. How do we actually get that clean, reliable water from the source and into somebody's glass? Any water supply project, whether it's for a tiny village or huge city, it all boils down to 3 fundamental questions. First, quantity. Is there enough water for everyone? Second, quality. Is the water safe to drink? And third, accessibility. Can people actually get the water, and can they get it reliably? You have to nail all 3. 2 out of 3 isn't good enough. Answering those 3 big questions takes a ton of math and a whole lot of looking into the future. It's kind of like a water equation, if you will. One of the absolute key ideas here is something called the design period. And just think about this for a second. Engineers aren't building a water system for the people who live there today. They have to try and predict the needs of that community 20, 30, sometimes even 50 years into the future. It's this incredibly high-stakes balancing act. If you aim too low, the system will be overwhelmed and fail. But if you aim too high, you've just spent millions of dollars on pipes and pumps that nobody's using. So, how on earth do they make that prediction? Well, they break it down. They don't just pull one number out of thin air. It's more like a puzzle. You've got the domestic demand. That's the water we all use at home. Then you've got institutional demand from places like schools and hospitals. Then commercial demand for businesses and industrial demand for factories. Each piece of the puzzle is calculated differently, but they all have to be added up to get that big final number. When it comes to our homes, the magic number is liters per capita per day, or LPCD for short. It's just a simple way of asking, how much water does one person use, on average, every single day? And for a place with modern pipes, engineers are typically planning for something in the range of 160 to 180 liters. Now, that's for everything. Drinking, cooking, showers, flushing the toilet. Believe me, it adds up really fast. Okay, but here's where it gets really interesting. We don't use water in a nice, steady trickle all day long, right? Just think about a typical morning. Everyone's waking up, taking showers, making coffee, flushing toilets all at the same time. That's a peak. So you can't design a water system for the average daily use. If you did, it would fail every single morning. It has to be built to handle that maximum demand, which can be nearly 50% higher than the average. That difference is called the peak factor, and getting that number wrong, well, it's a recipe for disaster. So let's zoom back out and bring this all full circle. From those huge global goals all the way down to the nitty-gritty math of peak factors. You see, every single drop really does connect. And really, this is the main takeaway. Actually achieving those massive sustainable development goals. It doesn't just happen in big conference halls with a lot of fancy speeches. No. It happens in the detailed, careful, forward-thinking calculations that an engineer makes for a single town's water supply. That local action, that is the engine that drives global progress. Which, of course, leaves us with a pretty big question to think about. Our world keeps growing, and with it, our demand for water is only going to get bigger. So the challenge, for all of us, is to figure out how we're going to balance our need for progress with the absolute necessity of protecting the very resource that makes all of it possible. And there is definitely no easy answer to that.